Hi, this is Mrs. Eggerding, and you're watching Unit 3, Video 6, and we're going to introduce you guys to the complex number system here. Back in the 16th century, when the mathematicians were working on solving quadratics, just like we are right now, they wanted a way to deal with the square roots of negative numbers. And so eventually, what came to be known as the imaginary number I was defined as the square root of -1. What they could do then is they could talk about things like the square root of 16 and break it into the square root of 16 times the square root of -1, and then they could call that 4I, replacing the square root of -1 with the I. Same thing with the square root of -48. It could be the square root of 48 times the square root of -1. 48 then is 16 times 3. And so this can simplify to 4I, and you're left over with the square root of 3. Now the other thing you're going to see is if we define I to be the square root of -1, we can also square both sides and talk about I squared being -1, because the square root squared will leave me with just the -1. These are the two properties and the two definitions that you're going to work with a lot when it comes to I. So what we've created by introducing imaginary numbers are these things called complex numbers. And complex numbers are always in this form, a plus bi, where a, this is called the real part, and the b is called the imaginary part. Now everything we've been dealing with up until now has been a pure real number. Things like 2 or 1/3, -16, pi, these are all pure real numbers. They're a complex number because they can be written in the form of a plus bi. It's just if it's a real number, that imaginary part is 0, but it's still a complex number. Same thing with pure imaginary numbers, things like 4i, I root 3. They can also be written in a form of a plus bi, but in the case of a pure imaginary number, the a value is going to be 0. Now these complex numbers, we can do a lot of things with them. One is to set them equal to one another. And in a case like this, finding values for a and b, if these two sides are equal, boils down to taking the real part equal to the real part. And for this one, the real part is 3a and 18. So 3a is 18. That gives me the a being 6. We then do the imaginary part is going to equal the imaginary part. So that's going to be -6 equals 2b. Divide both sides by 2, and you get b to equal -3. Other kinds of operations with the complex numbers involve a lot of the things we already do with radicals. For example, we can take something like -6, square root of -6 times the square root of -10, and talk about how to simplify it. And as we're doing these, the first thing you want to do is work with the I part first. Okay, so in this case, the square root of -6 becomes I square root 6, and the square root of -10 becomes I square root 10. Second thing I want to do is work with the operations. In this case, it's multiplication. So I times I is I squared. Square root of 6 times the square root of 10 is square root of 60. And then the last thing I want to do is simplify whatever I have left. We already talked about how I squared is negative 1, so make that negative 1. The square root of 60 is 4 times 15. Square root of 4 is 2. I'm left over with 15. And then negative 1 times 2 is negative 2. Square root 15. This process works for division as well, so square root of negative 20 over the square root of negative 2. Work with the I first, so this is I square root of 20 over I square root of 2. The operation next is division, so I over I crosses off, square root of 20 over square root of 2 simply becomes square root of 10, and that's as simple as that one can get. And the last kind of example is working with simplifying things that you would get from using quadratic formula. So something like negative 8 plus the square root of negative 128 all over 4. Again, work with the I part first. So I'll pull that out, and then 128 is 64 times 2 all over 4. Keep working with this. The square root of 64 is 8. I'm left with square root of 2 all over 4. And then the last thing I can do is simplify. So 4 goes into negative 8. That's negative 2. 4 goes into that 8 2 times. And there's the simplification for that one. So a lot of the rules for square roots we have are going to continue to work. Last operations we're going to do are the addition and subtraction. And if I take, again, complex numbers, a plus bi, and I go ahead and want to add these complex numbers together, it is still going to be real part plus the real part, so negative 3 plus negative 2 is 1. Imaginary part plus the imaginary part, negative 4i plus 6i is 2i. Just like you're combining like terms. If you want to talk about subtraction, same thing is going to go on there. So if I have 12 minus 5i minus 8 minus 3i, I take the real part minus the real part. 12 minus 8 is 4. Imaginary part minus the imaginary part. So negative 5 minus negative 3 is negative 2i. Just like combining like terms. Okay, last thing I want to talk about is this complex number system. All these numbers involving the a plus bi. The complex number system pretty much can be divided into two parts. And on one side we have these imaginary numbers, okay, where we've defined I to be the square root of negative 1, and I squared is negative 1. On this side, we have the real number system. And this is exactly the same thing that we did in Unit 1. And the real numbers can be divided into two pieces. The irrational numbers, like pi, or the square root of 2, and then the rational numbers. The rational numbers can break down further into integers, which are the positive and negative whole numbers. Integers break down to whole numbers, which is just 0 and all the positives. And then last, we have our natural numbers, or the counting numbers. Put all this together, and it's called the complex number system. So I know this assignment looks long, but most of these problems will go pretty quick. Page 113, it goes on to 114, 1 to 49 odd. It has you working with the vocabulary and doing some of those basic operations. Biggest things to remember, I is the square root of negative 1. I squared then is negative 1. We'll work with more of these in class on Tuesday.